same slope, but they have a different y-intercept. If you look back at the lines from our warm-up, you'll see that they cross the y-axis in a different spot, but they are angled the same. They have the same exact slope. So, knowing that, we're going to write an equation for a line that is parallel to y equals 2x plus 3, but a line that goes through the point negative 1, comma 6. Obviously, this line does not go through this point, because if I plug 6 in for y and negative 1 for x, I would get negative 2 plus 3, which would give me positive 1. Right? So this line does not go through this point. I'm going to write the equation for the line that does. Okay? So if I want to write the equation in slope-intercept form, I need to know two things. What are the two things I need to know to write an equation in slope-intercept form? It's in the name. The slope and the y-intercept, right? Why? It doesn't look like I have either of those. Hey, sure, that's fine. It doesn't look like I have either of those things. So how would I go about finding the slope? Alex?
Wait, what was the question?
How do I go about finding the slope?
Oh, it's in the equation.
It's in the equation. Where in the equation?
2.
2. If my line is parallel to this line, they should have the same slope, right? So I know right away that my m is going to equal 2. Now, how can I go about finding b? You said what? Plus 3 to the 2? Wait, 5? What are you talking about, plus 3? B equals 3? For this line, yes. I'm writing an equation for the line that's parallel to that line. Yes, just like that. Parallel lines. Okay? Parallel lines, I'll read the purple part again. Maybe we were still writing. Parallel lines have the same slope, but a what? Different y-intercept. Michelle, what can I do? Is the B 6? This one right here? Yeah, if my x value was 0, then b would be 6 for sure. Did we 7? Now we're just guessing. Let's see. Is there a lesson maybe aptly titled called Solving for B? Maybe from earlier in the month, 24 days ago. What did we do when we were solving for B, Matthew? That's right. We plug in an x and a y, which thankfully this problem gives us. X is negative 1. Y is equal to 6. And I can plug it in. Y equals mx plus b is going to turn into what's my y value given to me here? 6 equals my m, which we said was 2, times x, which is negative 1, plus b. What is 2 times negative 1? Negative 2 plus b equals 6. How can I get b all by itself? Adding 2. What is 6 plus 2? 8. So I could write the equation y is equal to what? What's my m again? 2. X plus, what's the b I just found? 8. So my original equation, they have the same slope, but a different y-intercept. We know for a fact this new equation goes through this line. So that's our answer. We just take the same m that the first equation gives you, use it with the point that it gives you to solve for b. There's my equation. Does that kind of make sense? Okay. It's the exact same thing as when we did solving for b, except instead of saying, oh, the slope is 2, it says it's parallel to this equation. But if they're parallel, they have the same slope, so it is just the same slope. Okay? Perpendicular lines are a little bit different, like we saw in the warm-up. Perpendicular lines have what's called inverse reciprocal slopes. Inverse reciprocal slopes. For example, if one of my slopes is 2/3, and I am asked, what's the slope of a line perpendicular to this line? Well, first of all, what does reciprocal mean? Yeah, Alex?
It's like switching.
Yeah, what gets switched?
Fraction.
The fraction gets switched. Okay, so 2/3 turns into 3/2. But what does inverse mean?
It's the opposite.
Opposite sign. So if 2/3 was positive, what is my 3/2 now going to be? Negative. Right? So we flip the fraction and we flip the sign of the fraction. If I have a slope of -4, Alex, question?
Oh, wait, are we not answering it?
Oh, no, yeah, I'm letting people write. Alex, what would be the inverse reciprocal of -4?
Positive 1/4.
Positive 1/4. Right? So if it says parallel, real easy, just take the same slope. If it says they're perpendicular, we got to do slightly a little bit more work. It's not that bad. We got to flip the sign and flip the fraction. Okay? Anyone still writing that? No? Okay. I got to flip. Let's write the equation. Same idea as before. We're going to write the equation for the line, this time perpendicular to this line. That goes through the point 3, 1. Everybody cool with that? So what's my slope in the line that it gives me? -1/2. So what's the inverse reciprocal of -1/2 going to be? So is that -2? Positive 2. If I flip 1/2, I get 2/1. If I flip the minus, I get a plus. So I end up with positive 2. Now I'm going to take that positive 2 with my x and my y and do the same thing we did in the first one. My m is 2. My x is equal to 3. And my y is equal to 1. So y equals mx plus b turns into 1 equals 2 times 3 plus b. Take a couple seconds and figure out what b is from that. What does 2 times 3 give me? 6. And when I subtract 6 from both sides, what's 1 minus 6? Negative 5. So I've got an m of 2, a b of negative 5. I can write the equation y is equal to 2x minus 5. Quick show thumbs, how much sense is this making? Thumbs up makes a lot of sense, seems pretty easy. Thumbs sideways kind of makes a little bit of sense, maybe seems a little off. Okay, good. Last thing we're going to talk about is figuring out if two lines are parallel, perpendicular, or neither. Are the two lines parallel, perpendicular, bless you, or neither? That's what we're going to have to figure out. All I really have to look at is the slope, but the slope is not always going to be easily identifiable. When can we think of an instance when the slope is not easily identifiable? Maybe a certain form that our equation could be written in. Yeah, Connie? Decimals? Well, I can look at it, right, and know that it's the slope. Is there a formula we talked about where the slope is not easily identifiable?
Standard.
Standard form. 3x plus 5y equals 10. I can't look at that and go, oh, my slope is 3, because my y is not isolated, right? And I could have 5x minus 3y equals negative 6. Do you guys remember how to put this in slope-intercept form?
Yeah.
Hopefully. It's on our test on Friday. Take a few moments, either by yourself or with someone in your group. Figure out what my two slopes are here, and then determine if they are parallel, perpendicular, or neither. So what you guys got for the first one?
Yeah.
Yeah?
Yeah.
I'll drop it down. We need to put the standard form equation in a formula that we can clearly see what the slope is when we look at it, right? It would be hard for us to go from standard to point slope. So let's go to slope intercept. We just isolate y. We had, pretty sure we did this in 2 whole lessons, if I remember correctly. For this one, I got to bring my x over, just like before. Divide both sides by -3. What's a negative over a negative again? Positive. Y equals 5/3 x plus 2. What do you think these lines are? Parallel, perpendicular, or neither?
Perpendicular.
Perpendicular. Give me a thumbs up, you say parallel. Thumbs down, you say perpendicular. Thumbs sideways, you say neither. Parallel, perpendicular, neither. Good. They're definitely perpendicular. How could I tell they're perpendicular? Because they intersect? I don't see a graph. I have no idea they intersect. Matthew?
They're opposites.
They're opposites? What do you mean by that?
Like they're all inverse. Like the numbers are inverse.
Close. Closer. Michelle? That's right. My slopes. Matthew, you were saying the same thing, right? You were talking about the slopes specifically, right?
Yeah.
Yeah, great job. So my slopes are inverse reciprocals. So these are parallel. Just kidding. Perpendicular. Perpendicular. Now, where would these two lines intersect? We know they intersect at a 90-degree angle. Anyone see where they would intersect if we graph them, Alex?
2.
At 2. They have the same y-intercept. So I know that that's where they must be intersecting, at that y-intercept. Because they can only intersect once. Perpendicular lines only intersect once. So they must be intersecting at the 2. Not that you need to know that, but it's just a fun little thing here. Questions I can answer about any of that? No? Do we need another example or are we good?